Hello, my name is Robin Mitchell and welcome to this episode for Electromaker. In today's video, we're going to be looking at what programming language you should choose for your next project. Now, choosing the right programming language for your project is an extremely important choice, and the reason basically comes down to the fact that let's say you're building a project, you choose some hardware, you choose a programming language that you're comfortable with, you start programming it, it looks like it's going to work, and then you get to some point where you start to hit some issues. Now, for example, one of these issues could be that there's no software library for a piece of hardware that you've chosen. You may also find that the language that you've chosen is too slow, it might be too large memory-wise, or it could just be too fiddly to use. And so choosing the right programming language can have an absolute massive effect on your project to the point where it can dictate if it succeeds or if it fails. And so the first step when choosing a project language is to decide what kind of project you're doing, or to be specific, the platform that you're running on. Now, when it comes to things that you can run your project on, there are two main platforms: a microprocessor or a microcontroller. Now, the biggest difference between a microprocessor and a microcontroller is that a microprocessor tends to be a computer with lots of RAM, lots of hard drive space, a big old processor, some kind of GPU, and some things like USB, PCIe, that kind of thing. Now, it doesn't have to have all that, but you generally categorize these systems with large RAM and big processors. On the flip side, a microcontroller tends to be a much smaller processor. It has limited RAM, but it has extremely fast GPIO access, which means you can toggle pins very, very fast compared to a microprocessor. And these kind of boards don't tend to run operating systems, whereas a microprocessor typically does. Now, the reason why this is an important thing to distinguish is that microprocessors have more flexibility in the language that they can use because they're bigger, beefier systems. So computer languages such as Python can be used because they're big languages with lots of libraries and lots of complexity condensed into very easy to use libraries, but because of that they use lots of RAM and processor time. So a microprocessor can basically get away with that. But a microcontroller has very limited system resources, and so you have to use these resources carefully. So of course Python may run on some microcontrollers, but sometimes it's better to use a language that's faster, more memory efficient, and more capable, especially when looking at things like GPIO and peripheral libraries. So without further ado, let's look at the first programming language, assembler. Assembler, also known as assembly, is a computer language that describes CPU instructions. And these instructions are natively understood by the processor being used. So what that means is when we write a program in assembler, we are writing actual CPU instructions that when compiled will be turned into hex numbers or bytes or bits or whatever that the CPU will physically take. It actually understands what it is and immediately executes it. There's no interpretation. There's no additional compilation steps. It literally just takes raw instructions in that you write and executes them. Now, the reason why this can be massively advantageous is because each instruction has a set execution time. So when you write some code in assembler, you know exactly how long it will take for the processor to execute it. As such, you can create programs that are very carefully timed. So let's say, for example, that you've got a VGA controller where you've got very specific vertical and horizontal synchronization signals. These things have to be timed very, very carefully. And that's actually quite easy to do in assembler because you can write some loops in basic CPU instructions. You know how each one or how long it takes for each one to execute. And so you can create a function that will perfectly create the pulses that you need, and you can time it down to the nanoseconds. Now, because you're writing actual CPU instructions instead of writing some arbitrary language that gets converted into CPU instructions, it's also highly memory efficient. Every single instruction that you write will be some number of bytes used up in RAM or ROM, and there's no hidden steps, there's no expansion, there's no compilation which adds additional instructions that you're not aware of. So when you write an assembler, you can control the amount of memory being used. At the same time, it's also very processor efficient because you dictate the instructions being read and executed by the CPU. Now, while this may sound really good, it has some major disadvantages, and one of these is that writing in assembler is very, very complex. But that's not because assembler itself is complex. In fact, the instructions are very simple: add, multiply, and divide. The challenge with assembler is that you have to code everything yourself. You might get lucky and use some pre-made libraries out there, but generally speaking, it's up to you. So let's say you want to do some floating point maths. If you're lucky and your microcontroller has a floating point unit, great, you don't have to worry about that. But in most cases, you won't have that kind of hardware, and you certainly won't have that kind of software support. So you need to know how to do floating point maths by yourself, things like lookup tables for, I don't know, sine, tangent, cosine, anything complex that goes beyond the scope of basic CPU instructions, you've got to do it yourself. As such, assembler tends to be reserved for things like hardware control of I/O pins, peripherals, and very carefully timed routines such as we said before, VGA signals, HDMI or sound. And finally, another big disadvantage of assembler is that it's not cross-platform. If you write some assembler code for the ESP8266, that's not going to port onto something like the Raspberry Pi 2040. So if you make a piece of code, or you design a project in assembler, and then you go, I want to use a different processor, you're going to have to rewrite everything, because none of that code is going to port over very well. The next language that we're going to look at is C. Now, C is an interesting language because it's one of the first main compiled languages for microcontrollers in general. It's obviously also very popular with microprocessing systems, and a lot of operating systems use C to drive their kernels. Now, C as a language adds a lot of flexibility and abstractation on top of assembler, so you don't have to worry about CPU instructions, you don't have to worry about timing. It adds lots of libraries that are very easy to use, and so your code is far more human readable. At the same time, if you don't use any device specific libraries, your code is also cross-platform. So if you write an application for one platform and then you port it to a different one that uses a totally different CPU, as long as the code written in C doesn't change and doesn't use device specific stuff, it will be cross-platform. That one will take it and execute it well. Now, we should mention that C is a compiled language, which means the compiler will take your C instructions and convert it into some kind of assembler that the CPU understands. So when we say it's cross-platform, what we mean is that the same C application can be targeted at different processors and still run. But you do need a compiler for each of those different processors. So let's say, for example, a new RISC-V chip comes out that's totally incompatible with everything else, which it wouldn't be, but let's say it was. You'd have to have a brand new compiler to port to that processor. Otherwise, your C application can't magically run on there. It needs to convert the C code into assembler, which then gets converted into some byte stream. Now, while C does add abstractation on top of assembler, so we can write human readable code that we can compile and don't have to worry about doing all the complex things like, how do we, deal with strings and stuff. It does add its own complexities, and one of these is through things like structures and memory allocation. Basically, because C makes things abstract, it also moves us away from the processor, and so it can be kind of hard to figure out what it's really doing under the hood. So let's say something goes wrong in a C program. It can be difficult to isolate and debug to figure out what's really going on. And so now we move on to the next language, C++. Now, C++ is very similar to C, except that they've added lots of stuff on top of it, and one of these things they've added is object-oriented programming. Now, one of the nice things about object-oriented programming is that you can do away with things like structures and lots of arrays and trying to track where all these variables are going for different objects that are similar in terms of properties. So let's say, for example, you have something like a car. All cars have some wheels, a paint color, and a size. So instead of having to create an array for each type of car, you can essentially create one class and then make lots of little objects based on that class. So they all have common properties, wheels and paint, but they have different values. And it's a very easy way to sort of track it all. But the beautiful thing about object-oriented programming as well is that the C++ runtime will sort all of that out for us. So if we create new objects dynamically, it will assign memory and then deallocate that memory. Now, while that's great for complex applications, it's not very good for a lot of low-end microcontrollers where resources are tight, because it requires lots of memory and a bit of processing power. So if you try to run C++ on a very low-end microcontroller, you may run into memory issues, and so your device might just suddenly reboot, and there'll be no reason as to why that's happened. It won't have like some debug message that says, oh, it's run out of memory. A lot of the time it will just flip and you'll have no idea why it's done that. So C++ is great for microprocessors, but not really targeted at microcontrollers. Now the next language we're going to look at is by far my favorite language, Python. Now the interesting thing about Python is that while assembler C and C++ are compiled, Python is interpreted. What this means is that instead of turning a piece of Python code into something that the CPU natively understands, a Python interpreter runs on a processor and takes in Python instructions and then interprets those instructions and then makes the CPU do something based on that instruction. Now, one of the big disadvantages of this is that Python interpreters can be quite bulky. So you can run them on microcontrollers such as the RP2040, but it requires a lot of resources and it severely limits what you can do in terms of the complexity of your program. However, one of the brilliant things about Python is that it comes with a lot of basic libraries and can be improved with the addition of other libraries, and there are thousands of libraries online. So a good example would be something like AI. To do AI in C and C++ can be very, very complex, and I've seen lots of code examples out there that are hundreds of lines long. But if you look at some Python examples for AI, you'll find that a lot of libraries out there can condense the entire thing into just 3 lines of code, which is honestly phenomenal. So you can make very abstract, complex projects extremely simple in Python. Now, as we said before, because it uses an interpreter, it means its performance and memory restrictions can make it difficult to run on microcontrollers. But if you've got a microprocessor, it's usually a breeze. Now, another big benefit of Python is that it's cross-platform. So long as your Python program doesn't use device-specific libraries, any piece of Python code that runs on one system will run on any system running Python. So this means that a lot of applications these days are being written in Python for that very reason. You can make a GUI application in Python targeted at Windows, but it will probably work for Mac and Linux as well. And if you write a piece of code that's designed to run on MicroPython on a microcontroller, that will probably run on a computer as well, so long as you're not using GPIO or UART and stuff. And so now we move on to a more strange language, Java. Now, the reason why I say Java is strange is because I kind of feel like it should have disappeared quite some number of years ago. Lots of other languages have come up that I would say replace it quite well. But from what I understand, because of the Android operating system using the Java virtual machine to run apps, it basically became the programmer's choice for making apps. Now, the interesting thing about Java is that it's very similar to C++ in its style and form. But while C and C++ are compiled, Java is a just-in-time compiled thingamajig. Basically, it's sort of a fusion between Python and C++. So you have a virtual machine that interprets Java bytecode, but when you create a Java program, you sort of compile it into a Java bytecode, which then gets run by an interpreter or a virtual machine. And what this means is that Java is cross-platform. So long as you have a virtual machine that can run on some target, then Java programs will run on it. And so that makes it very beneficial when working with lots of different devices. And that's probably why Android uses the Java virtual machine. But overall, you rarely, if ever, use it on a microcontroller, and it's almost always used on microprocessor systems. And now, ladies and gentlemen, we come to our last language, which is a guilty pleasure, Visual Basic. Now, the reason why I love Visual Basic is because it does exactly what it says on the tin. It takes the best parts of the BASIC language that was highly popular during the 80s and it adds it to the Visual Studio environment, which then adds all of the windows, forms and controls and all this kind of jazz. Now, another reason why I love it so much is that when you create GUI applications, you often have to code the elements, and I just find that fiddly and difficult and annoying. But with Visual Studio, you can create Windows Form apps and then you can add the buttons and the drop-down lists and all that kind of stuff. But the Visual Basic language makes it very easy to program in. Now, of course, you can't run Visual Basic programs on a microcontroller because it requires a Windows operating system to run. But what's really cool about it is that it's excellent for making form applications that communicate to a microcontroller. So let's say, for example, you've got an ESP32 and you want to communicate to it over UART. Visual Basic supports this using the serial port, and then you can code messages coming in and out, you can interpret those messages, and then you can send data, bring data, you can show that data on a rich edit box, or you can make data send by pressing a button. It basically is a really, really nice language when making complex programs to interface with a microcontroller. And so now we come to the most important part of this video. Which language should you choose? So let's start with the most basic kind of projects. Microcontrollers. If you're looking to use a microcontroller, then you're going to need to think about memory and processor restraints. So immediately, assembler, C, and C++ come to mind. So if you're trying to make a project that needs extremely fast access to GPIO, then again, C and assembler do very well. But if you need to time this extremely carefully, down to the nanoseconds, then assembler is the choice for you. But if you're looking to do things that are a bit more abstract, like control motors, send messages over UART, then C and C++ do much better. And if you find yourself that you're on a low-end microcontroller, then C is definitely the answer for you. Now, if you're using a more powerful platform, such as the Raspberry Pi 2040, then Python can be a really good option for you, especially if you're not doing things that are too complicated with GPIO and speed isn't an issue. So let's say, for example, that you've got a Raspberry Pi Pico 2040 and you need to control a few servos and then read some messages on a terminal on a computer. Python could be the solution for you. At the same time, Python also makes programs extremely easy to write, and it's very, very quick. So if you're trying to sketch a project very quickly, Python is an excellent choice. Now let's say you've got something like a microprocessor, such as a Raspberry Pi or a Windows machine. Things like C, C++, Python, and Visual Basic become quite useful because these languages can offer speed, they offer lots of libraries, and they're very, very flexible. But let's say that you need speed and performance where you're looking to deal with lots and lots of clients and lots of memory sizes, then C and C++ win. Now let's suppose we're doing a project which involves lots and lots of networking, such as an IoT server, then something like Python, C, and C++ become very good languages to use. But if you're using something like a Raspberry Pi, then something like Visual Basic is not an option. Now Python gives you the ability to make programs very simple. It makes the coding very, very easy. It's very quick to code in Python, but you get the performance issue. So if performance is important, again, C and C++ win. But if you're looking to get something working very, very fast, then Python is the answer for you. So to recap, if your project requires speed and memory requirements, then C and C++ will always win. But if you're looking to do something that requires timing in the nanoseconds, assembler is always going to be the answer. If you need something cross-platform and you want to be able to target lots of different devices, then make sure that a language that you choose is cross-platform. So again, C, C++, and Python. If you've got a Windows machine and you just want to connect to a microcontroller, then Visual Basic is an excellent idea. And finally, if you're looking to do lots of network processing and servers and all that kind of jazz, then again, C, C++, and Python. And if you're not using a Windows machine, then C++ and Python. And then if you want to get your program out as fast as possible, Python is the solution. Now, if you want to go ahead and start building your own projects and you're looking for some microcontrollers or microprocessors, head over to the Electromaker store where we have all kinds of things in stock. Link in the description below. Thank you for watching, and I'll see you next time.